Imagine standing on a calm beach, the air warm and still, the ocean stretching out like a vast, peaceful mirror. Yet beneath this serenity, an invisible battle of heat and wind begins, a silent spark that could ignite one of nature's most powerful and destructive forces, a hurricane. But somewhere far beyond the horizon, a tiny disturbance in the atmosphere begins a chain reaction that will grow into one of nature's most powerful and destructive forces, a hurricane. A hurricane doesn't simply appear out of nowhere. It starts as a cluster of thunderstorms over warm tropical waters, where the ocean's heat and the right atmospheric conditions, like low wind shear, work together to build a brewing storm. The ocean's surface must be at least 80 degrees Fahrenheit to provide the energy a hurricane needs. As the sun heats the water, it evaporates into the air, rising and cooling to form clouds. This cycle continues, pulling more and more warm air upward, creating a low-pressure area at the surface. Nature abhors a vacuum, so the surrounding air rushes in to fill the gap. This incoming air also warms, rises, and condenses, releasing heat and adding even more fuel to the storm. As the system grows, the Earth's rotation, a force known as the Coriolis effect, begins to twist the rising air, causing the storm to spin. In the northern hemisphere, hurricanes rotate counterclockwise, while in the southern hemisphere, they spin the opposite way. The storm continues to feed off the ocean's warmth, and if wind patterns remain steady, it starts to organize into a more defined circular shape with a clear center, the eye of the hurricane. The eye is a strange, eerie place. Despite the raging storm surrounding it, the eye is often calm, with clear skies and light winds. The air pressure here is dramatically lower than in the surrounding eye wall, and temperatures can be slightly warmer, giving a false sense of relief to those caught in the middle of the storm. Surrounding the eye is the eye wall, the most dangerous part of the hurricane. This ring of towering thunderstorms produces the strongest winds and heaviest rains. The winds spiral outward, forming bands of rain clouds that can stretch for hundreds of miles. These rain bands bring intense downpours, gusty winds, and sometimes tornadoes. A hurricane's strength is measured using the Saffir-Simpson scale, which ranks storms from Category 1 to Category 5 based on wind speed. A Category 1 storm might uproot trees and cause power outages, but a Category 5 hurricane can flatten entire neighborhoods with winds exceeding 157 miles per hour. But a hurricane's danger doesn't only come from wind. Storm surge, the abnormal rise of seawater pushed by the storm's winds, can flood coastal areas, sweeping away homes and roads. Heavy rainfall can trigger flash floods and landslides, even in areas far from the coast. Hurricanes often weaken once they move over land because they lose their energy source, the warm ocean water. Without that heat, the storm structure starts to break down, and the wind speeds decrease. However, if a hurricane moves back over a warm body of water like the Gulf of Mexico, it can regain strength, making its path even more unpredictable. The rain can continue for days, causing further flooding and damage. Scientists are constantly studying hurricanes, using satellites, aircraft, and computer models to better understand how they form and predict their paths. Early warnings save lives by giving people time to prepare, but hurricanes remain a reminder of nature's raw power and the delicate balance of our planet's atmosphere and oceans. So the next time you stand on a quiet beach and feel the warm breeze on your skin, remember that just beyond the horizon, the perfect combination of heat, wind, and water could be brewing the next great storm.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.